Okay, you guys, welcome to the first homework help for the year. I'm hopeful that this will help you out when you get stuck a little bit, and this is my first shot at recording it and putting it up online, so bear with me. I'm hoping my tripod will stay stable and so on. Okay, so our first question, this is chapter 2, number 1. Let me just straighten these out a little bit. I'll make it a little bit easier. Position versus time graph for a certain particle. You're asked to find your average velocity in your following time intervals. They give you the axes already labeled out, so that's kind of nice. The main thing you want to remember here is that your velocity is the slope of the line. So you're changing x on time. So read carefully and then just basically take the slope of your line. And don't worry about average. The idea here being that we have a straight line for all of them. So yeah, anywhere along that line you can consider it an average. An instantaneous velocity, by the way, would be if we took the derivative at, say, a single point, and that's very helpful when we have a curved line, but that's not the case here. So just, you know, distance over time. Okay, or I should say displacement. Ooh, let's be better. Okay, number 2. Number 2 is definitely trickier. When you look at this one, you're being asked to find your average speed and average velocity, but you notice they're not giving you time. So this one can be a little bit more challenging. Now, I'm going to actually say let's focus on part B before we focus on part A, because average velocity, that one's going to be kind of nice and easy since, well, let's face it, she's coming back to the same position, right? So if she's coming back to the same position, that should give you a big clue as to what her displacement is going to be. Remember, the big thing here is that velocity is displacement over time, and that's not spelled right, but you get the idea. Displacement over time. Speed is actually distance over time, and that's actually the trickier problem. All right, so average velocity, consider that she is coming back to her original starting position, so that is something important to realize. Okay, I've had folks do this problem a couple different ways. They've looked at it and just come up with, all right, I'll have her travel for 1 second and see how far she goes, and that way they end up with all the numbers they need. So you can do that too. You could say, okay, well, let's say she's traveling for 1 second. You know, so when she's going this way, she's going to actually go 5.3 meters, and then on the way back, she's still going to be going 1 second, and she'll be going back this way. Well, actually, no, I'm about to say that wrong. If she comes back from line B to A at a constant speed of 2.9 meters, they could say, all right, well, then how long is it going to take her if she's going this fast to make it all the way back 5.3 meters. And you can figure out the time here. You see what I'm saying? So you'd know this one would be 1 second, and then you'd have to figure out her time to go back this distance to the original starting point at this speed. And then your speed is going to be your distance, your total distance, over your total time. Another way you can do it is with variables. You can use d as a constant variable, or d1, all right, and it's going to, you know, she's going to be going that distance in a certain length of time, right? And then, you know what, never mind, let's skip that one. This is probably the easiest way, and I would say the most common way that people do it, okay? So, you know, say, all right, I'm going to go this far, this is my distance, and then set it the same back, figure out how long it takes her to go, and do total distance over total time. That's how I would go about number 2. That'll probably be the easiest one. Let's look at number 3. You're being given a function here. Don't let that throw you. All right, normally when we have a function, I would say, yeah, we're going to have to use some calculus, but we're not up to calculus yet, and it's really, really straightforward. Okay, so you're given a time interval here, and you're being asked for average velocity. So look, you know, my variable is t, so figure out, you know, what your initial position is, figure out what your final position is using your function, and then just use, you know, change in displacement over time for that. And it's the same thing here, it's just a different set of numbers. So again, use this with your function to figure out your position, initial and final, and then use your basic definition for it. This one is tricky because they don't give you the divisions on the axis. So it may be to your benefit to print this one out so you can actually label the axis. You notice I didn't do it correctly the first time because, you know, I can't read. Reading is fundamental. All right, but they tell you how the divisions go. Average velocity during the time interval, and then they give you your time interval. you are, again, looking for your change in position per unit time. Determine your instantaneous velocity by measuring the slope of the tangent line. Okay, now you don't, obviously it touches right there, but let's face it, this entire line has the same slope, so don't let that throw you. You can take the slope of that entire line. For what value of t is the velocity 0? You're looking for where you have no slope, or your slope is 0. So look at your curve, tell me where that is, and then read it carefully. All right, number 5. Number 5, the hare and the tortoise. Let's move this over. Let me fold this back up again. Okay, so you've got a whole bunch of stuff here on this hare and this tortoise, and basically the tortoise just keeps moving the whole time, the hare stops, the classical story. Okay, first of all, I want to point out your units. If you haven't noticed, they don't necessarily match in terms of the tortoise, actually not even in terms of the hare. So make sure that you are adjusting the units. That is really, really important. And the main thing that I would be asking yourself, okay, so you know, if the hare travels at this speed for 0.8 kilometers, you know, let's see, how much distance does the hare still need? That's a pretty simple subtraction. And then how long is it going to take for the hare to run that? That's the critical question. How much time is that going to take? You know, if the hare has, you know, 1 kilometer left, how long does it take for the hare to run that 1 kilometer? That is the time that the tortoise is going to still be running. Well, crawling, whatever. In any case, your time is the variable that matches. And then ask yourself, how far can the tortoise go? In that time. Once you figure that out, that's going to determine how close the hare can let the tortoise, you know, be. All right, if it turns out the tortoise can go, I don't know, 0.7 kilometers in this time frame that we're worried about, the time it'll take the hare to run to the end, well then, you know, he can only give him 2 kilometers head start, and then he's going to have to jump in and start running for the end there. Hopefully all of that helps a little bit, and I will do a second video for number 2.